Welcome to part 2 of a fresh start anaerobic soil disinfestation for high tunnel producers. Part 1 was hosted live last week and was recorded. We'll have it available on our website, www.capitalrcd.org, and it's available on our YouTube channel if you need to review it or if you want to share it with a friend. I'm Cheryl Burns. I'm the Project and Outreach Manager with Capital RC&D, and I'll be the moderator for the webinar this morning. Capital RC&D is a nonprofit organization that operates primarily in South Central Pennsylvania, but also coordinates some activities at a statewide level, like our support for high tunnel producers. We often work with a variety of partners, including the Natural Resources Conservation Service, or NRCS, and funding for this webinar series was provided by the USDA-NRCS. And they have funding available for the purchase of high tunnel technology for eligible applicants, as well as technical support. I'll provide a link and follow-up materials for anyone interested in learning more about this or other NRCS programs. Before we get started, I'd like to thank our presenter, Francesco Di Gioia, for taking the time to share his knowledge about ASD. We will have time at the end to address questions, and we're recording this session so that it can be reviewed later. I'll monitor the questions box, so feel free to ask any questions as we move through the session, or you can wait until we open it up at the end. If you need to ask me a question specifically, there is a way for you to select the chat box to come to me if you're having a problem. I'll monitor that as well. And so with that, I'd like to turn the webinar over to Francesco Di Gioia. Thank you for joining us.
Thank you, Cheryl, again for this opportunity. Good morning, everyone, and let's start. Again, as I mentioned last time, I really need to acknowledge a lot of people that work with me on this project, or I work with in this project. And the research I'm going to present has been mostly funded by the USDA Agricultural Research Service area-wide project on anaerobic soil disinfestation, which is led by Dr. Aaron Roscoff from the USDA-NRCS in Fort Pierce. And as mentioned earlier, this project has a lot of different partners. It's a multidisciplinary team, and I've been very happy and lucky to work with all these people. And most of the stuff I'm going to present are fruit of the collaboration within this group in different projects. So last time we talked about the principle of ASD, what is anaerobic soil disinfestation, how it's applied, a little bit of the history. And so today I just want to, with this slide, introduce again the concept and the step that we normally use to apply this anaerobic soil disinfestation treatment. In this slide, we have our soil, and the first step of the application of the ASD treatment is to amend the soil with a labile carbon source. So when we talk about labile carbon source, we're talking about something that has a lot of sugar, soluble sugar that is available, and that are going to feed the microbes. Now, because microbes need also nitrogen, it's important that we have a good carbon-nitrogen ratio. And so some of our organic amendment carbon sources may not have enough nitrogen, or they may have too much nitrogen, so we need to adjust that in the best way, and we'll talk a little bit about this today. Then the second step is to mulch the soil, possibly with totally impermeable film, to avoid any gas exchange, so that while the oxygen is consumed, there is no more oxygen coming in. And then the third step is to saturate the soil with water. And this can be done via drip irrigation normally. And saturating the soil, we said last time, doesn't mean to flood the soil, but really what we want is to apply, to bring the soil to water holding capacity in a way that we saturate the micropores that are in the soil, and so there is less oxygen. And then we said also that the water, the initial irrigation water, helps also to diffuse all the byproduct of the anaerobic soil disinfestation. And so once we do this 3-step, what we have is we create anaerobic condition, and we said that our threshold is 200 millivolts. Once we achieve a redox potential below 200 millivolts, then we are talking about anaerobic condition. And under this condition, what we have is we have an anaerobic decomposition of the organic material that we have applied to the soil. And this process is mediated by facultative and obligate anaerobic microbes. So there is also a shift of the microbial population from aerobic to anaerobic. And then what happens is that the sugar that is available, the carbon that is readily available, is going to go through a fermentation process that leads to the production of acetic acid, lactic acid, propionic acid, butyric acid, formic acid, valeric acid. And at the same time, we have production of CO2, methane, and other volatile organic compounds like aldehyde compound. So all these products that we see at the end of the fermentation process are most probably responsible for the suppression of our soilborne disease. And so this is really important. And then because we apply also nitrogen, also the nitrogen goes through a lot of transformation. So normally it's metabolized and is transformed to ammonium. And then the ammonium is partially immobilized by the microbes and partially can be transformed into nitrate. And the nitrate may be subject to denitrification under anaerobic condition, which may lead to the production of nitrous oxide. So the nitrous oxide is this compound here. Or another possibility, depending on the pH of the soil, is that we have production of ammonia. So higher is the pH, more production of ammonia there will be. And the ammonia also can be toxic for a lot of living organisms in the soil. So this could be also part of the treatment effect. So after this brief introduction, one thing I want to express today is with this conceptual map, that probably is not that clear, but one thing I want to say is that when we apply anaerobic soil disinfestation, we have these 3 components. So the carbon source and eventually supplementary organic amendments. Then we have the mulching and also the initial irrigation. Each one of these 3 components has an impact on the soil properties. So soil physical-chemical properties, but also biological properties. We after that we apply this treatment, the ASD treatment, depending on the type of carbon source that we are using, the type of supplementary organic amendment, the type of mulching, the amount of water that we are applying at the beginning. This is going to affect our redox potential, the pH of the soil, and then the level of moisture. The mulching can affect a lot the temperature of the soil. And then this is going to have an impact also on the nutrient content and the cation exchange capacity of the soil. And depending on how labile the carbon is and the ratio between carbon and nitrogen, this is going to greatly affect our soil microbial community. And this in turn will affect also the nutrient. And then everything has an impact on the soil-borne pest and pathogen, and on the availability of nutrients in the soil. And in turn, this is going to affect our crop health, the plant growth, and our yield. Now, so ASD is affecting all these. With this treatment that we are doing, we affect all these aspects of the soil and then of the plant growth. But everything is modulated by environmental factor. So this is, like we said last time, this is a biological treatment, microbial population, microbes are involved, and microbes are really affected by environmental condition, by the temperature, for instance. And so it's really important to understand this, that the anaerobic soil disinfestation treatment is quite complex, and its complexity is also determined by the fact that it's subject to environmental condition. And so we really need to put ourselves in the best condition to have an effective treatment without having any negative side effect. And so in this table here, I just summarized what are the application conditions that were tested, that have been tested here in US in different states and through different studies. And as you can see here, the main carbon source used are rice bran, molasses, and then have been tested also dry molasses and brassica mixtures. So like, cover crop residue or crop residue, cereal rye also as a cover crop. And as you can see here, the rate, the application rate are pretty variable. So depending on the condition, there is really a wide range of rate that have been tested. And in some systems, there was no need to apply any supplementary organic amendment. In other systems, instead, it was observed that the application of composted poultry litter, for example, really helped the efficacy of the treatment combined with the molasses. Here in Tennessee, researchers have tested also the use of feather meal as a supplementary organic amendment. And then regarding the mulching type, there are studies done simply with polyethylene mulching, so regular polyethylene mulching, and but many studies, especially in Florida, TIF has been used, total impermeable film has been used, and this is really kind of more effective, especially if we are using opaque film, not clear plastic, because it really holds all the gas. So it's really quite impermeable. There's a layer in the middle that is really impermeable to gas. Then the duration of the treatment, normally most of the study conducted on vegetable were conducted within 3 weeks. So the treatment lasted only 3 weeks. After that, the plastic was punched and the crop was transplanted. There is a study here that I mentioned that was done on fruit tree, prunes fruit tree, and this was in California, and the treatment lasted 6 weeks. And this was done before planting fruit crop. And then for the initial irrigation, also there is large variability. Most of the study use 50 millimeters of water. So this is basically 2 inches of water as initial irrigation. But for example, in California, they have been testing levels that were higher at the beginning. And I know that there is research going on trying to reduce the amount of water, initial water. The same thing if we look at what has been done in other countries, in China, Japan, Netherlands, and Spain, we see that there is a variety of carbon sources that have been tested. In Japan especially, they've been working a lot with ethanol and with wheat bran beside rice bran. There are studies done also on broccoli residue and grass in Netherlands, also using green manure, and in Spain there has been study done on a variety of carbon sources. And more or less, depending on the content of carbon of these carbon sources, the rate is defined based on the percentage of carbon, the application rate. And so it's really variable because the most probably the carbon content of these carbon sources is variable. Also here we have different type of mulching. A lot of people are using regular plastic mulch or in some cases VIF, virtual impermeable film. And the duration here is also ranging from 2 weeks up to 15 weeks, which is really long time. And the initial irrigation condition, for example, in China, they have tested flooding the field, and then here is 200, 500 millimeters, again, 2 inches of water. So it's really variable. Um, so this is important to mention because depending on the environmental condition we are in, the rate, the application rate, the type of carbon source can change a lot. And so every situation has to be evaluated depending on the environmental condition. So if we're talking about high tunnel production system, then our main thing is to understand when is the best time to do the treatment. And so depending on the location, if we are talking about Pennsylvania, we want to look at the zone map, which zone we are in, and because this is going to affect most probably our crop cycle. In this graph here, you can see what is the average temperature, average minimum and max temperature in a high tunnel over 1 year, so from January to December. And in this this line here, this dot line is what is our ASD minimum temperature. Basically, we need a minimum of 60 Fahrenheit degrees to have an optimal microbial growth. So if we don't have this temperature, then the microbial activity will be much slower, and the treatment will not be effective. ASD has been tested under cold condition, especially in Japan, and from the data that we have so far, a minimum of 15 Celsius degree, which correspond to 60 Fahrenheit, is what is optimal, is required for ASD. Then, if we go even to higher temperature, the treatment will be surely more effective. The higher is the temperature, the better should be, although there is a limit to that high temperature. So if we look at this data, if we assume that this is the average in the last, I don't know, 10 years of temperature in an eye tunnel, then the window that we have to apply ASD treatment in natural condition in an eye tunnel without any heating system and anything like that will be from mid-April to September. And sorry, but this is like this were average temperature taken in State College. So we are talking about central Pennsylvania, and it may be different in other places. So this is the optimal window that we have. And if we look, for example, at the crop cycle of tomatoes, basically it overlaps with this window because that's our best window to grow tomatoes. And in most of the cases, growers will start growing tomatoes in high tunnel around March or mid-March, and then go all the way to the end of the summer until September. And so this may be a challenge when to apply the ASD treatment under the condition of Pennsylvania in high tunnel. And sometimes we know also the crop cycle is shifted even earlier because we are eating our greenhouse, our high tunnel, and so that allows to have an earlier cycle, and then most probably when we have an earlier cycle, we may have sometimes here at the end of the crop cycle, in which we can do the ASD treatment. Sometimes we laid the plastic, we prepared the soil in high tunnel already at the beginning of January. This was a picture taken in January 2nd this year. And so the question is what we do if we are in the middle of the winter. Can we apply ASD in those conditions? Normally, without having any temperature control system, I will say is difficult. But one thing that we can do is to increase the carbon source rate, because increasing the carbon source rate, we may have better condition. The other option is, this was tested in Japan, in soilless system, is to somehow control the temperature of the soil using hot water, and also using clear plastic to increase the temperature. So this is something that I've never tested, and I don't know how feasible it is. I assume it's kind of difficult and could be expensive. But so what I think is that if there is a need to do ASD treatment, it will be better to do it in the right window over the summer. Now, if we are not growing tomatoes and there is other crop cycle, let's say we are growing lettuce or other cool crop like other more cool season crop, most probably we can have a window of time in which we cannot grow this crop between June and July, and that is actually the best time of the year to apply this treatment. Another possibility is that if we have movable high tunnels, then we can rotate the soil, and that will allow us to have more flexibility on when to apply the treatment. So this is something really important. We need at least this 60 Fahrenheit of temperature. Then, like mentioned earlier, the type of mulching and the color of the film may affect the temperature, has a big impact on the temperature, and so it may have an impact on the efficacy of the ASD treatment. The higher temperature is obtained with clear plastic, then black plastic is the one that follows. And then if we have reflecting mulch or white mulch, then the temperature effect will not be as important. And under this condition, of course, like under any condition, of course, the use of TIF versus regular plastic may help to hold the gas, and so to create more anaerobic condition over like the first few days. So really, now, of course, the cost of the plastic may be different, and so that is something that growers should evaluate based on their specific situation. Among the factors that contribute to the efficacy of anaerobic soil disinfestation, one thing is really key is the carbon source, and because that is the way we are feeding our microbes and like starting this whole process. And so the question is, what is the ideal carbon source? The ideal carbon source has high labile carbon content, so high content of soluble sugar. So we need material that is fresh, is not woody, or it's not lignified. And the carbon nitrogen ratio should be between 20 to 1, 20 carbon to 1 nitrogen, to 30 to 1 carbon nitrogen ratio. And we are going to see this a little bit more in depth. Then it's important for the reliability of the treatment that the material that we use has consistent properties. It's constant. It's not changing all the time, because if the content of carbon, the content of nitrogen are changing, or other factors like the humidity of the carbon source is changing, then that may affect the treatment, and sometimes we don't understand what is happening there, and there is something related to the carbon source itself. Then possibly we want something that has not that much of nutrient content, especially nitrogen, because an excess of nutrient may determine an excess of nutrient release, and so you know, part of that may be used to fertilize the crop, but may be released also before we actually transplant the crop. So we don't want that. Then the material has to be liquid, or it has to be a fine material, easy to grind, easy to apply. Liquid, of course, is is better, is easier to manage. And what is really important is that the carbon source is something that is locally available and is low cost. And so for this reason, there is not one type of carbon source that works for every location, for everything, but we need to search what is our best carbon source, depending on where we are and what are the potential material that we can use. So here just a few picture of like solid carbon source, like with bran and rice bran. And usually this material is already fine, and and we just need to apply it and incorporate into the soil. So we have to till it within the root zone. So that requires like an additional step, the fact that we have to till this material. If we work with a liquid carbon source, it may be different. For example, this is in the bucket, is the melassa as you normally see it. Like this is a feed grade melassa, so it's really viscous, and it should be diluted into water, at least 1:1. And once it's diluted, it can be injected through drip irrigation, or it could be sprayed like on the top of the soil. And the nice thing of working with liquid carbon source is that it may reach a lower depth compared to the, the solid carbon source without having to till the soil. Although anyway, we have to form the beds and do that type of work. Here in US, based on my knowledge, we cannot use ethanol, bioethanol, but in Japan, they have been really successful using bioethanol. And they apply it through drip irrigation with water solution that go from 0.5 to 2% volume to volume. So it could be interesting in the future if we could use this as a carbon source. And in Japan, they have a product that is labeled, is registered for this application. So it's like a regular agrochemical that they are using. And actually is allowed also for organic production. Now, if we have to look at what we have in terms of carbon source available in our environment, we have to, be really look at different things. And for example, here we have grape pomace, so the wine grape byproduct. Maybe there is byproduct from breweries, from apple cider industry that we could use, or from the mushroom industry. All these are carbon sources that may be suitable for ASD and that we could test. Then in some cases, it's possible to use crops, residues, or cover crop. And actually, those are many times like the cheapest carbon source available. Doesn't require any transportation. You can grow it. For example, this is fava bean. It is a leguminous, produce a lot of biomass, and we have fruit that we can harvest as a crop, and then the residue can be incorporated in the soil, and this fresh material is not lignified, and so this could be an interesting combination to use. And at the moment, we are doing with one of my students, Luca Vecchia. He came from Italy to do this project. We are looking at different cover crop that may be used as a carbon source for ASD. And so we are looking at annual ryegrass, Persian clover, buckwheat, cowpeas, crimson clover, field peas, forage radish, mustard, oat, rye, and then sorghum Sudan grass hybrids, and also sun hemp. And so we are just testing this right now in a greenhouse study, and then later on we'll test this also in the field. Um, One thing is important in selecting our cover crop is for the purpose of ASD is that we have to define, we have to find the right cover crop for the season, the growing season, the growing time that we have. We have to choose something that has a rapid growth so that in a month or in a month and a couple of weeks, we can, go from seeding to incorporating it in the soil. It has to be something that has high biomass, also an optimal carbon nitrogen ratio, as we saw before, and high labile carbon, so a lot of sugar, soluble sugar, and possibly should have low seed cost and low requirement. And so, depending on when we are applying the treatment, the crop may be different. So we are working on this, and we'll let you know soon, hopefully, what we find out. Um, so when we talk about carbon sources, what we said here is that the ratio between carbon and nitrogen is really important. And as you can see here, it ranges a lot. So in this table, we have from 8.8 for the composted poultry litter to almost 60 for the sorghum Sudan grass. And this is really important, not only because the carbon nitrogen ratio determines the decomposability, how fast this material degrades, but it's also important because we are applying not just carbon, we are also applying nutrient. So depending on the carbon nitrogen ratio and the application rate, the amount of nitrogen, for example, that we are applying with our treatment can vary a lot, and sometimes it's really high for a crop. And one thing I want to highlight here is that usually animal material, composted material, has more nitrogen, as a lower carbon nitrogen ratio, which means more nitrogen in proportion to the carbon. So these are really helpful material because they have a lot of microbes that bring like we bring a lot of microbes in the soil with this material, but they also bring a lot of nutrients. So we have to be careful about this. Now we said that our optimal range of carbon nitrogen ratio is 20 to 1 to 30 to 1. And normally, so when we have a carbon nitrogen ratio higher than 20 to 1, we create conditions that are unlimiting for the microbial, which means that there is enough carbon and not enough nitrogen for the microbes to grow. So in that case, what happens is that all the nitrogen that is in the soil is taken up by the microbial community, by the microbes, and we have what we call nitrogen immobilization. And normally, higher is the rate, lower is the lability of the material, and lower will be the microbial growth and the nutrient release. On the opposite side, when we have a carbon nitrogen ratio that is lower than 20 to 1, C, the carbon is what is limiting, and this determines a faster microbial growth and like the higher release of nitrogen and other nutrients. So that's why the carbon is really important. And of course, we want something in between because we want to have a fast growth, fast microbial growth, but we don't want to have issue with nitrogen or with other nutrient in excess. So just to give you an example here, these are the analysis, the composition of molasses, a composted poultry litter that we have been testing a lot under the condition in Florida. And this has been tested also in other states, and this molasses is really gaining great interest as a carbon source because it has a lot of advantages. And as you can see here, the compostable 3 liter has a good amount of nitrogen and also a good amount of phosphorus, while the molasses has also a good amount, pretty high amount of potassium. So how does this reflect to to the efficacy of the treatment and then the entire crop? Is there any issue related to this? So this was our question, and using suction lysimeters, what we did was to analyze what was happening in the soil solution. And one thing that we observed was that with comparing chemical soil fumigation with true rates of anaerobic soil disinfestation, we observed that nitrate was much higher in the chemical soil fumigated plots than with ASD, and this was true at 7 and at 14 days after we applied the treatment. And so why this is happening? Basically because during our anaerobic phase of the treatment, the ammonia is partially immobilized because we have a lot of carbon from the microbes, and so it's not released as a nitrate. So the nitrate content is pretty low, while there is a prevalence of ammonium. So we don't have any risk, like we have limited risk of leaching for nitrogen under these conditions. So this is really interesting, and it's something that we are not used to because normally we don't work with anaerobic conditions. But then, because we have a lot of phosphorus in the compostable 3 liter, you can see here that we have really good levels of phosphorus for the first 3 weeks in the soil solution. This phosphorus may be subject to loss because right now we don't have any plant during those 3 weeks. We have plants only after. So this is a concern. And then potassium also is pretty high. And so the higher risk is really for phosphorus. Potassium is, even if it can be leached out, is also an important nutrient for our crop. And so one thing is important. I'm saying this because it's really important that we adjust our fertilization plan based on the type of carbon source. So we need to know what is inside our carbon source before we start working with this material, before we define what is the application rate. Now, most probably also like the treatment effect and the nutrient contributed to achieve higher yield in both ASD treatment compared to the chemical fumigated control, but then it's also a matter of money. So how much does it cost to apply all these molasses? And so to, especially if we are working in a closed environment, in a protected environment where there is no rainfall, we want to be careful about the amount of nutrient that we apply, especially if we apply animal organic amendment of animal origin. Those usually have a lot of phosphorus, and we don't want to go over a certain amount of phosphorus in our soil because we don't have any leaching rainfall, and so we'll be accumulating nutrients. So we have to be careful about that. And so having this in mind, one thing we did was to try to reduce to half the rate of molasses that we were using and composted fertility we were using. And then expecting that this treatment, this half rate treatment, will be less effective in controlling weeds, we try to combine ASD with an herbicide. And so these were the rate that we tested for compostable 3 liter and molasses, and this was the way we applied the herbicide. And as you can see, the herbicide did not affect the efficacy, the redox potential. We achieved very good redox potential both in with and without the herbicide. And of course, the herbicide improved the control of the weeds. And here you can see the effect of the full rate of ASD controlled the weeds pretty well. So this is a different timing. And this was not different from the chemical fumigated control, while when we halved the rate and we did not apply the herbicide, this was the effect on the weeds. So there were more weed. And to give you an idea, this was the half rate without herbicide, and this was the half rate with the herbicide. It was much cleaner. So Then our interest here was also to see if we could reduce the nutrient in the soil. So we checked that, and as you can see here, with this rate of molasses, there was much less issue, much less concern regarding the phosphorus. And again, the nitrate level was significantly lower in the both ASD treatment compared to the chemical soil fumigated control. And potassium was still higher in our ASD treatment. So this is a more sustainable solution. And what we saw is that also in this case, we had higher yield or similar yield to the chemical fumigated control with the ASD treatment. And we also did an economical analysis that actually is still under evaluation. Like this paper is under evaluation. And what we saw here is that we increased the cost of the treatment before planting, like it is higher compared to in ASD compared to the chemical soil fumigation. But then because we have higher yield, we have higher net return. So this is promising, but this is again something that changes from condition to condition. Like if we are working in open field, the cost is one thing. If we are working in an eye tunnel, then the cost of ASD may be marginal compared to the value of the crop. So that is something that is really important to consider. Another way to reduce the amount of nutrient that we tested was the use of composted yard waste as a substitute of the composted poultry litter, because this has less nutrient. But this is a material that also has a higher carbon nitrogen ratio. And so what we observed here is that again, we like in this case we had more anaerobic condition, and so the level of nitrate was lower with the ASD treatment compared to other treatment, and here didn't make a big difference using the composted yard waste. But then when we look at the potassium, there was a difference here. And this was repeated at also at 14 days after planting. So this is something interesting. The problem with this is that it was the composted yard waste was not as labile as the composted poultry litter, and so we didn't get equivalent anaerobic condition. So the anaerobic condition achieved with the half rate of molasses was much higher than, with the composted poultry litter was much higher than the anaerobic condition have obtained with the same rate of molasses, but with the composted yard waste. So this is really interesting to consider. Now, quickly, I want to show you here how important is the rate effect, the carbon source rate effect. So we did a pot study in which we use pretty high level of molasses. And as you can see here, increasing the molasses rate, we obtain higher level of anaerobicity. And as we did this, we also obtained a decrease of pH while increasing the molasses rate. So this rate here are basically, so this is no molasses, this is ASD1, then this will be ASD2, ASD3, which means 3 times ASD1, and ASD4, which is 4 times ASD1. And so what we observed here is that there is a negative relationship, an inverse relationship between cumulative redox potential and soil pH. And this is basically determined by the organic acid that that were produced during this process. So what we did was we sampled the soil at different timing, we extracted the soil in a certain way and analyzed the content of organic acids. And this is what you see is lactic acid. So with the treatment that didn't receive anything, it's down here at the bottom. Then this is ASD1, ASD2, ASD3, and ASD4. So it's like increasing the rate, we are increasing the amount of lactic acid. Similar trend for other, like acetic acid is another compound that is produced, propionic acid, and there depending on the treatment, the effect, the prevalence of one or the other organic acid may change. But so this was the total organic acid content over the three weeks treatment at different timing. And as you can see, increasing the rate, basically we're increasing the amount of organic acid. One thing is really important to know is that, anaerobic conditions are not good for our crop. So we want to make sure that after that we apply the treatment, the soil goes back to aerobic condition. We need oxygen again in the soil. And so we need to be careful about that. So with very high rate of carbon source, we can kill the plant, basically. So before we do that, we really need to aerate our soil and make sure that there is not like the soil is back with oxygen. And there is different ways to see at that. And so one thing is to use sensors. Those are kind of expensive or require some equipment, some wiring in the field, so it's not optimal. The best, this allows to continuously monitor what is happening in our soil. But one of the most practical tool that we have is usually when we have an anaerobic process, an anaerobic fermentation, a fermentation process, the soil will smell. So the smell will tell you that there is something going on. And then when you aerate the soil and that smell is gone, you can it's safe to plant. And the ideal thing is to punch the holes, wait 1-2 days, and then you transplant your crop. Another thing that can be done is to monitor the pH of the soil. Usually the pH goes down and then goes up again little by little. So that could be another tool. And another tool that is more economically feasible for growers may be to use this indicator of reduction in soil. Here is PVC pipe that are painted with iron oxide paint. And basically, depending on the anaerobic condition that are achieved, like we have this paint that is basically eroded. And so based on this, we can say how much anaerobic the soil went. And then we can have an idea of, how long it will take to go back to oxygen conditions. So I think I have, I am more or less on time, and I will be happy to answer any question that you have.
So thank you, Francesco. I know I learned a lot of great information. And I know this is a new topic for many producers and probably some technical advisors that are on. And folks, if you have questions, and I see that there is one here already. Actually, let me pull that up real quick. So Brent is asking, how well does this work in high pH soils?
So in high pH soil, I think there is no problem because the effect that this treatment will have is to reduce the pH of the soil. Usually, for example, we have been working with composted poultry litter combined with melassa a lot, and the composted poultry litter has a pH that is around 9.5, and the ASD treatment usually takes that down to 6.5, and then it goes back up. So there is no real problem associated with that. The main thing that we have to pay attention with is if we use a carbon source that has a lot of nitrogen, and that nitrogen is transformed into ammonia. The ammonia may have a killing effect, but then we need to be really careful about when we plant our crop. So there is some tools that can be used to monitor the ammonia under the plastic. And that will give us an indication of what is happening and when we can transplant.
Great. And I may mispronounce this, so I apologize if I do. In calcareous soils, the calcium carbonate will buffer against the change in pH. Will this interfere with the process?
No, because our point is not to achieve a certain level of pH. As long as the material is fermented and there is production of organic acids, those organic acids will act. And so I don't think the calcium carbonate is going to buffer. There's going to be a buffer effect, but that doesn't prevent, because like the organic acids is one of the aspect. Then there is also other organic volatile compounds that are acting. So it's really a complex thing. And one thing of this is, like we attribute the main effect to the pH, lower pH and to the organic acid, but there is also a microbial component. Like we are shifting completely the microbial community. Like we are, it's kind of resetting everything in the soil, and so this effect is also not, I think, not affected from the type of soil, but it's more like the type of microbes that we have in the soil.
And a follow-up question, actually, separate question, I'm sorry. Does the soil texture, so sandy soil versus clay soil, affect the efficacy of ASD or the duration that it will need to be applied to the soil?
Yeah, I think that is important, and that may affect especially the amount of water that we need to saturate our soil. And so, of course, in a sandy soil where we have a lot of drainage of water, it may be it may take more time to achieve anaerobic condition than in a more clay soil. So, and the other difference is, the difference in incorporating the material and the organic matter content of the soil. That also can make a difference. But in terms of efficacy, I mean, what is important is to develop the right recipe for that specific soil, for that specific temperature, for that specific condition. So that's why this is a little bit complex and requires some assistance at the beginning. But then once you define what is the optimal rate and the optimal condition, there should be no problem.
Okay. Let's see if there's any follow-up or other questions. I do have one. So can you recommend the first couple steps that either producers or technical advisors should take before considering ASD?
Well, what I think is that, as we mentioned last time, ASD is a tool, a technique that can be used in integration with other tools that we have. First of all, if we have a specific issue, a soilborne issue, we have to look at, is ASD effective toward this or not? So, for example, in Pennsylvania, the main thing I heard that growers that work in I-tunnel are having as an issue is nematodes after certain years that they have been growing the same crop under I-tunnel in the same soil. And so ASD is pretty effective in controlling nematodes. It has a good effect on the weed, but it depends also from the type of carbon source and the efficacy and the type of weed and the weed pressure. So sometimes for weed, we may need to integrate ASD with something else. So the first thing is to assess what is your problem that you want to solve, what you want to tackle. And then the next thing is to really apply the treatment knowing what is in your carbon source. You need to know which nutrients are there, and that will help to predict what is the pH of your carbon source, and that will help to understand what is going to happen in your soil. And while the treatment is going on, it's important to have some tools to monitor what is happening there. So we want to be sure that there is something that is happening. So the smell is something that will tell us, but and the other important thing is to define the right window. So most of the time we are growing tomatoes over the growing season, but if we have a problem, then we need to solve that problem. There is not that many solutions, and so this is one of those. And to work over the summer may be the best thing, especially the first time we are doing it, because that will give us like I will not start doing the treatment under a cold environment, because that may be, may result in something that is not optimal.
Okay. And I have a follow-up question here to some of the first questions. So, are there indicator microbes that you are monitoring to determine that you have adequate disinfestation?
Well, I am not a soil microbiologist, and so I'm not the right person to answer this question, but I've been working with soil microbiologists, and I know that there is certain type of microbial population that really indicates that the treatment, that the soil went anaerobic, and there were certain conditions. And so potentially, yes, it's possible to monitor the what is happening at the microbial level, but the tools required for this type of monitoring may not be easily available for growers, at least that I know right now. Maybe in the future that will change. Because like Jason Ong, one of my colleagues that has been working on this, he has been testing some kind of rapid tools to monitor at least the shift of microbial population in the soil during the SD treatment.
Thank you. Excuse me. And while we wait to see if there are any last questions coming through, so for anyone looking to find additional information or learn about the latest information that's coming through, do you have any sources or recommendations where people can look?
Well, the main source are publication that we have published so far, and like most of the publication are available in on the web page of like, for example, on my web page you can find a few publications, and then the other thing is there are some websites that are not like complete yet, or they are not like there's a web page or a flyer on ASD. Probably we will do something more on this in the future, but if you have specific question or you need articles, like go on my web page on ResearchGate, or shoot me an email and I will try to provide you the sources. There are some very good book chapters that have been written on this, so that provide comprehensive information, and there is a lot of publications that are going to come out soon. So yeah, there is some information, and right now the number of people that are working on this subject is increasing, and so I expect that in the next few years we'll have more and more information coming out.
And for now, I don't see any other questions. So, Francesco, thank you so much for taking the time to prepare both, last week and this week, and to being so willing to address questions, both mine offline and the ones today. I really appreciate it. And
thank you for this opportunity again. And yeah, we will work more on this, and we'll try to communicate more what we are doing.
Wonderful. Well, thanks everybody, and enjoy your week.
Thank you.